Hello, I'm Enrique Treviño and I want to talk to you about my paper, The Least Kth Power Non-Residue. So a bit of background on the problem. So if you let g of p be the least quadratic non-residue, then heuristics using probability suggest that g of p is smaller than log p times log p. What can we prove if you assume the generalized Riemann hypothesis? Then Ankeny in the 50s showed that you can change this to log squared p, so almost what we expect. Eric Bach in the 80s made this estimate explicit by showing that it's less than or equal to 2 log squared p. And then recently, last year, Lamzuri, Lee, and Soundararajan improved this to changing this 2 to a 1. And they also improved what happens asymptotically. Now the best unconditional results are nowhere near as good as this. And the best so far is a result from Burgess in 1957, where he proved that the least quadratic non-residue is at most p to the 1 over 4 root e plus epsilon. But this result is not explicit. So what's the best explicit result? In 1971, Norton proved that you can bound it by 4.7 p to the 1/4 log p if p is 3 mod 4, or 3.9 p to the 1/4 log p if p is 1 mod 4. You may notice that this is not quite that, but this works for all p instead of just for large p. So my work was in proving this result of Norton to changing this 4.7 to a 1.1 and this 3.9 to a 0.9. So the main tool I used to improve this result is that I used more careful combinatorics to bound this character sum. So before, this factor here was much bigger. Norton knew that you could get this back in the 70s, but he never published a proof of this. And Booker proved this for quadratic characters, but one of my applications here is that I proved this result for any character, not just quadratic characters. I hope you enjoy this paper.